All right, so for this lesson, you're going to need some graph paper and some sort of straight edge or a ruler. And you'll also need some type of crayon or colored pencil or something to do a little bit of coloring in. So we are going to continue on with our linear inequalities that we started yesterday. And today, of course, my document camera doesn't want to work with me. Today we're going to be graphing. And as soon as the sun freezes, we'll be able to see our first example. So this is in slope-intercept form. So I know that the slope is 3/2. And I know my y-intercept happens at the point 0, -1. So I'm going to start at 0, -1. And I'm going to go up 3 and over 2 to the right and up. Since this is a positive slope, I'm also going to do the same thing in the opposite direction, down and left, so that I have all of these points in a line. So that part is exactly the same as it was graphing the other day with just a linear equation. What makes it different is my inequality sign. So this tells me that the points on the line where y is equal to 3/2 x minus 1 are not included. And the way that I show that those points are not included is when I connect these dots, I'm going to do a dashed line like that, showing that the points on my line aren't actually included. So the next thing we're going to do is figure out where the points are that qualify as a solution to this statement. So the point that I usually choose to test is the origin. So I'm going to test the point 0, 0. And if 0, 0 works and makes a true statement, then that tells me that's part of the solution. So I'm going to substitute in 0 for x and 0 for y. Well, 0 is in fact greater than -1. That is true. So 0, 0 is part of the solution. So I'm going to shade in everything that is up here above this line because 0, 0 is included as part of my solution, because this is in fact true. So thinking back to yesterday, if it's a true statement, that means that point is part of the solution set. So all of these points in here in this pink shaded region are part of my solution. Next one we're going to look at is y being less than or equal to 2. We know from graphing last week, this is a horizontal line. So I'm going to go to where y is 2. And it's going to be a horizontal line going straight through y equals 2. And since my inequality sign has an equal to, in this case, all of those points are, part of my solution set. If I could draw a straight line using a ruler. We'll just pretend that that actually went through all of these. We'll make it work. So all of the points on this line are also included as part of my solution. So in this case, if it's in y equals form or slope-intercept form, it's a little bit easier for us to figure out the shading. So here I'm saying all of my y values that are less than or equal to 2. Well, that's everything down here. So all of this is part of my solution set because that's where all of my y values are less than or equal to 2. Next one we're going to look at here is in point slope form. So I can pull out the slope and I can pull out the point. Oops. So my slope is -2, which is technically over 1, and I like to write that just to remind myself. And remember, in my point slope form, it's the opposite of what I see. So it would be -3 and +1. So I'm going to go to -3, +1, and I'm going to use my slope to create some points for this line. And remember, it's negative, so it has to be a decreasing line. And because of my inequality sign, this will be a dashed line because there is no equal to. So when I connect these points here, oops, if I could actually draw them through the points instead of over to the side, it's going to be a dashed line. So then again, I'm going to test the point 0, 0. So 0 minus 1, and I need to figure out if that's greater than -2 times 0 plus 3. Well, this simplifies to -1. 0 plus 3 is 3, times -2 is -6. That's true. So I'm going to color over the origin because the origin is included in my inequality statement. So it's everything over here. So now if I were to ask you if the point 3, -1 is part of our solution, well, I would go to 3, -1. That point would be here. And since this point is inside of our shaded region, that would in fact be part of our solution. All right, so graphing in standard form. Remember, in standard form, I look for my x and y intercepts. So for an x-intercept, I make y equal to 0. Now, yes, it is an inequality, but when I'm looking at my x and y intercepts, I'm going to treat this like an equation. Oops, this should be 0. Because these are the points that are going to make this line. So 2x being equal to 4, so x would be 2. So this coordinate is 2, 0. And then same thing for my y-intercept, except I'm going to make x 0. So 2 times 0 plus y equals 4. So then y would be 4. So this is 0, 4. So those are the 2 points I'm going to graph. 2, 0 and 0, 4. Checking out my inequality sign. This is going to be a solid line because there is an equal to sign. So connecting these dots. Still not doing very well, even using a ruler, but we'll pretend. It's fine. And then I'm going to use 0, 0 again as my test point. So 2 times 0 plus 0 greater than or equal to 4. Well, that would be 0 being greater than or equal to 4, and this is false. And since this is false, that means I cannot color or shade over top of 0, 0 because it is not part of my solution. So I need to do everything up here that's on the other side from 0, 0. So it's going to be everybody up here. So similar to our previous example when I had y being related to a number, it was a horizontal line. Remember, if it's x being related to a number, that's a vertical line. So I'm going to go to where x is 1. There is no equal to, so my line has to be a dashed line. So I'm just going to not even use a ruler. And now I want all of the x values that are less than 1. So that would be everybody over here. Well, and it includes these points right in this space that I missed. We like the vertical and the horizontal lines. They don't take a lot of brain power. All right, last two. I have another standard form for us. So I'm going to find my x and y intercepts. So for my x-intercept, y is 0. Well, let me make an equal sign. Hoy vey. So here x is going to be 6. 1, 2, 3, 4, 5, 6. And for my y-intercept, negative 3y equals 6, because x is just 0. So that tells me y is negative 2. Looking at my inequality sign, we're going to be dashed because there is no equal to. So when I connect these 2 points, make a dashed line. And I'm going to test the origin to see if it's true or false. Well, 0 is in fact less than 6. So that means that I am going to color over top of the origin. So it'll be everybody up here, like so. Last one, we're going to do point slope form. So I have a slope of 1/2, and my starting point is 2, -1, because I'm doing the opposite. So I'm going to go up 1 and over 2, and I'm going up and right because this is a positive slope. There is an equal to, so this is going to be a solid line. And then let's see if the origin works. And if it does not work, I need to shade on the opposite side. Well, this would simplify to 1. This is going to be 1/2 times -2. Well, half of -2 would be -1. 1 is not less than or equal to -1. This is false. So I cannot shade over top of 0, 0. I have to go to the opposite side of the line. So it's everything down here. And that's graphing linear inequalities.